Hello, everyone. My name's Riley Dickens, and I'm a consultant at Encryption Consulting. Encryption Consulting covers all the aspects of security concerns, such as data security, key management, and privacy. Today, we will be dissecting the Capital One cyber attack, the root cause of the attack, and how such attacks could be prevented. Let's start with the introduction. The company Capital One is very well known in the finance industry. This company deals with lots of PII, or personally identifiable information, to provide services such as credit cards, savings accounts, loans, and more to its customers. The company got some public attention when it declared that it will move fully to the cloud and ditch all its data centers by the end of 2020. Although it is a bold and commendable move, unfortunately, Capital One soon became a victim of a cyber attack, which negatively impacted its reputation. It is estimated that around 140,000 social security numbers and 80,000 bank account numbers were compromised, along with other personally identifiable information. What's more, the attack was a very common and well-known cyber attack called a server-side request forgery, or SSRF. To understand how this attack works, we first need to understand how a web application works. A web application deals with two things: request and response. A web application typically consists of an application server and database that each deal with business processing and data transactions, respectively. A client system is also used in a web application, which interacts with the user and deals with requests. A client system can send requests, or in simpler terms, perform API calls to the server-side endpoints. Based on the request, the application server performs computations and interacts with the database, and then sends the response. It should be noted that in a microservice architecture, the application server can also perform API calls to other application servers. The entire process can be made secure by multiple means. Capital One did it by using a sophisticated data store called AWS S3 bucket and incorporating IAM, or Identity Access Management. IAM provides credentials to authorized parties and provides them roles to access services. During API calls, the server side first fetches the credentials from the request header, then, if matched, performs the rest of the operations. In theory, this system should be very secure. However, just like signature forgery, if a hacker gets access to one of these credentials, it could just use that to perform API calls, and the server side would never know the difference. This method of attack is simple and very common. The Capital One hack allegedly started by exploiting the poor firewall architecture of the public cloud where the credentials were kept. Once that was done, the attackers simply used one valid credential to perform a malicious API call, which had custom code to steal the sensitive data. It should also be noted that other than this, many other terrible things could be done by a successful API call. One can perform SQL injection, insert malware into a file system, or use ransomware to encrypt data. But all of these could be prevented by following some best practices. There could be many options to do so based on the individual tech landscape. Generally, we recommend the use of a few checkpoints, such as classification and encryption of sensitive data, incorporating hybrid cloud if possible, and avoiding complete migration to public or community cloud. In any case, it is advised to perform risk analysis and have appropriate controls in place. Some controls include having multi-factor authentication in place where it's applicable, and monitoring all microservices and incoming and outbound traffic in real time. This concludes the video for today. Thank you for watching. If you liked it, please leave a like and subscribe below. Contact us at encryptionconsulting.com if any confusions arise, or if you simply want more detail. Thank you.